Okay, moving on from our adding, subtracting, and multiplying matrices, we're going to be looking at 2 by 2 determinants and inverses. This is going to lead us into doing 3 by 3s a little bit later. So we're going to start off small with just 2 by 2s. It's fairly simple, pretty straightforward. Okay. All right, so the first thing we want to make sure we identify is what a square matrix is and what the identity matrix is. A square matrix is anything that is has the same number of rows and columns. So 2 by 2 with 3 by 3, like the examples on this slide, and then also 8 by 8, 12 by 12, 13 by 13, 20 by 20. You can get larger and larger and larger and larger. Okay, so all of these are different square matrices. The rows and columns have to be the same. The next thing is an identity matrix, which is what we're going to be using to help identify inverses, if something is an inverse. And so what that is that it's basically all zeros in the matrix except for ones going diagonal from the top left to the bottom right. Okay, so if you make it larger, so if you did a 4 by 4, it would be 1 with 3 zeros, then it would be 0, 1 with 2 zeros, and it would be 0, 0, 1, 0, and it would be 0, 0, 0, 1 for a 4 by 4. Okay, a 1 by 1 matrix is just 1. Okay, there's no zeros in it if it's a 1 by 1. Okay, so that's going to help us identify if we have inverses or anything like that. Okay, so first we want to identify if they are inverses. And so to identify if they are inverses, what we're going to do is that we just multiply. So you're just going to multiply these. Okay, you're just going to multiply them. And when you multiply the first one, you should see that you get, yes, it is an inverse. Because when they are multiplied, you end up getting your identity matrix. Okay. So like the first one, if we go -2 times -8, that gets a 16. -15 times 3 is a -5 times 3 is -15, getting us a 1. And so you just do a multiplication of them and identify if it is or not. Now if we look at the second one, we have 2 times -2, which is -4. And then we're going to add that to 3 times -1, which is -3. That gets us a -7, so automatically we know it's not an inverse. So the second you have one that does not work, the whole thing doesn't work. Okay, so the second one doesn't work, the whole thing won't work. You need it to start off with 1, 0, 0, 1. Okay, next thing is the determinant. Now the determinant is helps us with finding inverses. So instead of having an inverse given, it's going to help us find what it is if we're just given one matrix. And so the determinant, if we have, let's say, the determinant A is equal to the matrix, this right here, DET, and this, how it's written, will be the notation for it. So DETA is asking for the determinant of matrix A. And what it's equal to, where it looks like it's just absolute value bars, so you see how up here these are closed brackets, and this is just lines. On the determinant, that tells you that it's asking for the determinant. So if it's just lines straight down, it's asking just for the determinant. Now what you're going to do is you're going to go down minus the up. So what you will do is that you will take the upper left and go down to the bottom right. You're going to multiply those, and then you subtract it by the bottom left to the upper right that are multiplied. Okay, so you see here I did it in colors, okay, the red and the blue. So you do the red and the blue. Okay. And so then you subtract and you get a number. That is your determinant. So down minus up. Okay. That tells you your determinant. Now the determinant, just whatever the number is, isn't super helpful except in one case. Now that one case is leading us to inverses. So let's say we look at this one. So we have 4, 4, 2, 4, 2. So if we did a determinant of this, if we go down and then up, it would be 8 minus 8, which gets us 0. Okay, so that determinant would be 0. Now the second one, you see how there's variables? You still do the same thing. You still multiply it. So you do the down. So the down, which would be -3k, and you're going to subtract it by whatever the up was. 3 times 3 is 9, negative k times 3 is negative 3k. Since we multiply that, it would be 9, and then we go plus 3k. And then we combine and simplify, we get negative 9. Now sometimes you will still have a k value in it. That's fine for your determinant. Okay, the k won't always disappear. Okay. So that's finding the determinant. Down minus up. Okay, now your inverses. So your inverse, the key thing here, remember I said that there's only really one special number for the determinant that you have to worry about, and that's 0. If you do a determinant and it equals 0, you cannot get an inverse. There's no inverse that's possible. So first thing you always want to do is find the determinant, because you're going to use that number to find your inverse. And if it's 0, you're done. You don't have to do anything else. You're done with that. Okay. Now the last part on this slide, the a negative 1, is the sign for the inverse of a. Okay, which is 1 minus which is 1 over the determinant of a, and then you see here the part that's changing is that these are changing positions, a and d, and then you're adding negatives to b and c. Okay, that's the only thing that's changing. So basically, once you find the determinant, you just reorganize your matrix, and then you're just going to multiply it in. So you would multiply this 1 over determinant of a in. So if you ever get a determinant of 1, it's super easy to do that. But now you see why it makes sense that you can't get a determinant of 0 for it to work, because you would get 1 over 0, which isn't possible. So now let's look at these. So the first one, we want to find the determinant. So basically we're using this equation. So let's first find the determinant. So it would be down minus the up, which would give you 6 minus 4, which is 2. So we have a determinant of 2. So now we're going to rewrite this, where we're going to have 1 over 2, the determinant, and then we rewrite our matrix. So it'd be 3, negative 4, negative 1, 2. Okay. And now all you're going to do after that is you multiply it in. And so that's why I have the decimals instead of using a fraction. So 3 over 2, which is 1.5, negative 4 over 2 is negative 2, negative 1 over 2 is negative half, and 2 over 2 is 1. Okay. Now we would do the same thing on the next one. So down, so 3 times 6 is 18, minus 9 times 2, 18, and we get 0. So since we have a 0 as our determinant, we would say that it does not exist, or there is no inverse for it. Okay, so no inverse for that one, and right then we're done. Okay. All right, now the key thing with inverses here, what we really like using with the inverse is that we are able to find a missing matrix that are being multiplied. So if you remember in previous PowerPoints what we were doing, or previous videos, we were looking at finding the matrix that is being added or subtracted or multiplied by a scalar. This we're going to use inverses to find if we're multiplying 2, because that's a little more difficult to find. Just using it, just written it straight out. And so if we have, let's say, a times x equals b, if we want to solve for a, now a lot of people will go, oh, you're just dividing. Well, technically no, you're taking the inverse of whatever a is. It's just when we take the inverse of, let's say, 3x equals 6, the inverse of 3 is 1/3, and we can just write that as divided by 3. So we find the inverse of a, and then we multiply it by b. So if we look at this one, first thing we want to do is identify, can we find an inverse for a? So we find the determinant. 4 times 2 is 8, minus 5 times 1 is 5. That would get us 3. So our determinant is 3. Okay. So right now we know, yes, we can do the inverse. We can go through all this. So it's going to be 1/3. So our inverse would be 1/3. And then we switch positions, 2, 4, and we put a negative on these, negative 5, negative 1. Okay. And then we would multiply it in. Now, I'm going to say let's hold off multiplying it in to start. Okay. Um, let's hold off multiplying it in to start. And so what we're going to do instead, based on how mine comes out, is that I've already multiplied it in. Now, that's fine. You can do that, but you'll have to deal with fractions. If you keep the 1/3 out, you're left with 2, -5, -1, -4, or no, +4. Whoops. +4. You can multiply this matrix, the green one, by this. Okay? And when you multiply it, you'll get a new number. You'll get a new matrix. Now, this new matrix that you would get after you multiply these two would be -10, 2, 17, and 2. Now, if you multiplied this right here, you would get what's right below it. -10/3, 2/3, 17/3, and so on. Here, you see it's not the same, but you forgot that we have to do 1 over the determinant 1/3, which we didn't do on this one. So we would have to multiply our answer by 1/3, which gets us our answer. Both ways are acceptable. Either one, it does not matter. Okay. All right, now onto your IRAT. So your IRAT, just two problems. The first one, just find the determinant of it. So find the determinant of the matrix 5, 2, 1, 3. And the second one, I want you to find the inverse of it. So first identify if you can. So if you can't, you just say there is no inverse. And the reason is because the determinant is 0. If you can, then take the extra step and find what the inverse is, which is, again, just flipping the numbers and changing the sign. Okay? Super easy.